With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, a particle is moving in a circle of radius 2 upon 3 meter and mass of the particle is 2 kg. Kinetic energy of the particle depends on distance h traveled by the particle as kinetic energy is equal to 4h to the power 4. The angle made by net acceleration with the radial acceleration when the particle rotates by 60 degree is. So here we can say, suppose this is the circular path in which the particle is moving, describing an angle of, we can say here 60 degree. That is when it moves from this point to this point. Angle made at the center here is 60 degree, which here is our pi by 3. So initially the particle was suppose at this position A, and here now the particle reaches to this position. Suppose this position here is now, let's say B. Now here from A position to B position, let's say when it moves in this direction, so we can say here its kinetic energy at this instant. We can say here velocity will be along tangential direction, acceleration will be, let's say, towards the centripetal direction. So this is the centripetal acceleration, and this here is the tangential velocity, where kinetic energy here is given to be as, we can say, 4 into h to the power 4. Now kinetic energy here can be expressed as our half m into v square is equal to 4h to the power 4, where m here is given to be 2 kg. So substituting value of mass as 2 kg, hence v square is equal to, this comes as 4h to the power, we can say here 4. So v square value comes as 4h to the power 4, where radius here is given to be 2 upon 3 meter. Hence the value of centripetal acceleration here can be said as is equal to v square upon r. Now v square we have calculated as 4h to the power 4 divided by radius we have here as 2 upon 3. Hence the centripetal acceleration here in terms of s comes out to be our, we can say here as 6 into h to the power 4. So this is the value of centripetal acceleration. In the similar manner, if we, let's say, express here velocity, so we can say here this velocity comes out to be our 2 into, we can say here as s square. Now we need the value of tangential acceleration. So tangential acceleration, as we know, is a rate of change of velocity. That is, we can say here is dv by dt. Hence the tangential acceleration will be along this direction, suppose. So this is the tangential acceleration. So we can say this comes out as dv by dt, whereby we have velocity as 2s square. So this here is our 2s square. So we can say here tangential acceleration coming out as 2. Let's say we bring outside. So this is d by dt of s square. Now differentiating this, we can say here this comes out as at is equal to, now this we can say here applying chain rule. So this comes as d by ds of s square into, we have here as ds upon dt. Hence this can be written as tangential acceleration value as 2 into, we have here as 2s into ds by dt is v. Here we have v as 2s square. So substituting this, hence tangential acceleration here comes as 4s into 2s square. So we can say tangential acceleration here is equal to our 8 times, we can say as s cube. Hence this is the tangential acceleration. Now the question here says the angle made by the net acceleration with the radial acceleration when particle rotates by 60 degree. So we can say here the net acceleration, let's say by parallelogram, will come along this direction. So this is the net acceleration. We need to find the angle made by net acceleration with radial or centripetal acceleration. We require this angle. Suppose this angle here is theta. So if we draw perpendicular from here to this, we can see here this is tangential acceleration, so this shall also be our tangential acceleration. Hence if we draw this triangle here, we can see here in this triangle we have, let's say, this angle here is required theta. So this angle here is theta, this angle is centripetal acceleration, this angle is tangential acceleration, and this is the net acceleration. So we can say here this, let's say tan of theta here can be written as equal to AT divided by we have here as AC. Now tan theta here is AT by AC, where we have value of AT as calculated here as 8s cube divided by value of AC we have here as 6s to the power 4. So this comes as 4 divided by, we can say here as 3s, where s is the distance traveled. Hence we can say this distance here moving from point A to B here will be equal to, we have here as r into this angle. So r into, we can say as theta. Hence radius here we have here as 2 upon 3 and theta angle here is pi by 3. So this angle comes out to be, let's say, pi by 3. Hence distance traveled as 2 pi by 9. So we can say here this is equal to 4 upon 3 into s here is our 2 pi divided by, we can say here as 9. Hence this simplifies as cancelling 2, cancelling 3. So 3 here and into, we can say here as 2 divided by, in the denominator as pi. So this comes as 6 upon pi. Hence our required final answer here is theta is equal to, we can say here as tan inverse we have here as 6 upon pi. Hence tan inverse 6 upon pi, which here we can see as option number 2. Hence we can say 2 is the correct answer. So we have 2 as our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.